Okay, well, we're going to talk about information technology network infrastructures. We're going to talk a little bit about information systems. What are they? The internet, client-server computing, wireless, and the web. What is an information system? Well, simple. It is a information system store, process, transmit, and present data for knowledge management, record keeping, decision making, support planning, and process automation. Okay, they exist at the edge of the network, and you can have them in desktops, you can have them in servers, or you can have them in embedded systems. What is a desktop? Well, it's the largest market by dollar. Obviously, everyone has a desktop/laptop, and desktop computers are no longer normally $1,000 to $10,000. It would be nice to have a $10,000 desktop, but that would be overkill. They're more your end user type. They focus on clock rate as a measure of performance, whether versus servers, which are demand for reliable file and computing services. And they have the emphasis on availability and scalability, and throughput is also a key requirement. You might want to know that one. Embedded systems. They're the fastest growing segment of computing market. You can have it hard or software, either way. They're embedded into all sorts of environments, such as your phones. You make custom hardware or software. There's all sorts of things you can do with embedded systems. The problem is they have severe memory and power constraints. So that's why you have smartphones. The battery dies too much. Okay. Technology trends. We had an integrated circuit board, integrated circuit technology, where the transistor density had to quadruple every 10 years. They were old-fashioned. Then we went into the DRAMs. The density increased 40 to 60%, and the cycle time decreased. Then we went into the magnetic disks, which were your hard drives, and the density became more and more every year, and then access time kept increasing with every decade. In other words, better access time. Network technologies, the bandwidth on infrastructure normally doubled every year. And that was what was happening, probably 5 or 6 years ago. What is the internet? Well, the internet is an interconnected network of thousands of networks and millions of computers linking businesses, educational institutions, government agencies, research institutions, and individuals. Well, what is the World Wide Web? Well, it's a service of the internet. Don't confuse the two. The www provides access to web pages. The internet is just the network itself. The history of the internet can be segmented into 3 different phases. We have the innovation phase. It was back in the 60s with ARPANET and DARPA. Then we had the institutionalization phase, which came in mid-70s, where it was more of the academic, and they were providing funding and a real reason to give it to everyone. And then we have the commercialization phase, which we're currently in, where private corporations create and expand the internet backbone. All that's based on what we call a packet switching network, where when you get into intro to routing or advanced routing, you'll get more into the understanding of what packet switched means. But basically, all it means is a method of slicing digital messages into packets, sending them across the medium, whatever that medium may be, and then reassembling the packets on the other end. You're going to have routers that do, and those routers are the specific hardware that actually sends these communications via the backbone. So they route the traffic, if you will. They're that traffic cop saying, okay, you're going to go from point A to point C, but you've got to come through me to go over there. That's really all it is. Routers do what we call a routing algorithm to ensure that they get there. And there's tons of those, and like I said, you get more in depth into intro to routing and advanced routing. But here's a simple packet switched information. You'll have, I want to communicate with you as the original text. The text is then digitized into bits at the physical layer. At layer 2 is broken into, the bits are broken into packets. Well, actually that's layer 3. And then the header information is added to each packet, indicating where its destination, the flow control, how many bits are in total. It's kind of a little out there. But like I said, you'll get more of that in the intro to routing area. What is TCP/IP? Well, that's the Transmission Control Protocol, Internet Protocol. A protocol is basically just a set of rules that govern the transmission of data. That's all it is. And it provides for error checking. TCP establishes connections among sending and receiving web computers. That's the key. TCP is a connection-oriented protocol. IP, it's a layer 3, and all it does is provide you with an IP for your system. TCP/IP model is broken into 4 different types. You have the network interface layer, you have an internet layer, you have a transport layer, and an application layer. Your TCP/IP protocol, your network interface layer, is basically your physical layer compared to the OSI model. Your internet layer, which is your layer 3, and then you have your transport, which consists of layer 4, and then application, which is 5 through 7 of the OSI model. And that kind of gives you an idea of where the different protocols interlie. The network interface layer, you're going to have your Ethernet, your token rings, all your 802s, okay? 802 dot whatever it may be, 11s, 3s, 5s, 4s. They're all right there. Your internet layer is where you develop your IP address. Your transport layer is where the TCP suite comes into play, that's where it establishes the connection for all the applications, which are your HTTP, your Telnet, your FTP, and your SMTP, and things of that nature. Internet addresses, we have 2 different types. We have IPv4 and IPv6. IPv4 can handle up to 4 billion addresses. It is a 32-bit address that is broken into 4 octets with a value of 0 to 255 for each octet. IPv6 can handle up to 1 quadrillion addresses and is a hexadecimal 32 character long address. Basically, the routing of the messages, the TCP protocol breaks it into packets. The packets then traverse the network to get to where it needs to. They're reassembled on the recipient's end, and that's how packet switching works. Domains and URLs. Well, a domain name is an IP address that is related to a colloquial name. Well, the colloquial name is a human name or a natural language name. It's easier to understand, like rose.edu, okay? Instead of having to remember whatever Rose's IP address is. That's based on what we call the DNS, or the domain name system. It is a server service that allows IP addresses to be expressed in a natural language. Instead of saying 216.200.247.134, I can just type in cnet.com. It goes to the same place. The Uniform Resource Locator, or the URL, is addresses made up of or used by the web browsers to identify that location of that content on the web. So how's the web really broken down? Well, we have several different layers. The root server, that is your dot. When you hear .com, .com is the second layer. The dot is the root server. You will never be able to get to it, so you can't just hit period and hit enter and expect to get to the IANA. But that's essentially where the root is. Everything is connected to that dot. Okay, .com, .edu, .gov, things of that nature. AOL.com would be a tertiary level. Okay, that means it's AOL.com. It'd be AOL.com dot in when you were to do it out. For example, if I wanted to go to the 4th level, it would be accounting.nyu.edu. Okay, so you'd have ACCT, NYU, EDU, period. And that's how the hierarchical domain name system is. Well, what is client server? Well, very specific, very easy to understand. You have a client and you have a server. The client then asks the server for applications or for a service of some kind. The server then authenticates it, makes sure it happens, then they will provide that service to that client. That's essentially what a client server is. Here's an example of it. You have the network. They all go to the server. The server finds the information in the database and sends it back to the client. The internet today is basically you have I should say the client server model is coupled with an hourglass. Basically, you have all your layered architecture where it has grown up, and then the 4 layers of your network technology substrate, your transport services, your middleware services, and your applications. And those are kind of expressed in this next diagram here. All your network technologies, you're going to be all your 802s, the point-to-points, things of that nature. Layer 2, that's going to say what type of transport service are we going to do. Your middleware services are security, your multimedia, your electronic money, your name servers, things of that nature. And then finally, layer 4, your applications. It'll be your browsers, your emails, your teleconferencing utilities, things of that nature. Here's even a higher level view. You're going to have a backbone, which comes into the regional hubs. The regional hubs then supply localized backbones out to your local service or server. For example, if we went to a regional host on a T1 line down to NYU, it would hit their POP or their SMTP. You can have client addresses. It goes right into their network and the offices, things of that nature. That's basically how it flows. And what is an internet backbone? Well, basically it's a high bandwidth fiber optic cable. Okay, going to the network service providers or the NSPs. There are different types of fiber optic cable. You have single mode, multi-mode. Each one of them will give you a different data rate. Data rate is also returned bandwidth, or how much data can be transferred over that communications medium within a fixed period of time. And it's going to be expressed in either bits per second, kilobits per second, megabits per second, and gigabits per second. And then pretty soon it'll be pentabits per second. But that's where we're going to at this point. Where are your hubs going to be? Well, hubs are where the backbones intersect with the regional and local networks, where you're going to have a backbone owner that connects to one another, your network access points, your metropolitan access exchanges. Basically, it's going to allow that ISP to get those lines, okay? Campus area networks, things of that nature. ISPs lease those internet access to the home, to homeowners and businesses and stuff. And the major national ISPs, your AT&Ts, your Sprints, things of that nature, are those are your bigger ISPs. What's the difference between an intranet and an extranet? An intranet basically it's your organization, it's an internal website. And then your extranet is an internal website that faces outside so that people can access your internal requirements. What is a wireless internet access? Well, wireless is considered your last mile. You have telephone based or computer network based, depending on which way you want to look at it. And here's some different ways you can look at them. You have a GSM, CDMA, TDMA, 3G, 4G, 5G, 2.5G, the general packet radio service. There are the GPRS, the cellular digital packet data, or CDPD, and then you have your single carrier radios. We also have the 802 standards. You're going to have 802.11b, 802.11a. Remember, A came out after B. And then you have WiMAX, which is your 802.16, which is going to be your metropolitan area networks. And then Bluetooth. And not to be confused, but PAN is now different than Bluetooth. Bluetooth is not part of your PAN. It's called a body area network now. So I'm not trying to confuse you, but to give you a little bit more heads up, you'll learn more about that in wireless. Different standards. You have your GSM and your CDMA. Basically, those are the global type of systems. Your GSM is in Europe, and CDMA is here in the United States. Your 3G networks are your third generation, or your GPRS, or basically your phone is all digital at this point. And then you have wireless web, where you have your WAPs, and then we finally get into the 4G. You've probably seen this commercial, and you look at the picture, you'll understand what I'm talking about. Long-term evolution, essentially you have 3 towers that interconnect to provide you the service. So you get 3 different avenues instead of 1 for your phone. The trend started back in 2004. 2Gs basically were going to be flatlined, and then 3G started taking off into terabytes. Now then we look at the 3G where it's going to supposedly die down by 2014, which it already has. Now you have 4G and it's taking way off. And now we're going to get into the 5G. It's going to look exactly the same thing. It's right around the corner. The LTE network promises to be higher throughput, low latency, global mobility. You're going to have 5 to 12 megabits download, 2 to 5 megabytes upload. So you can see a drastic difference between 2G and 3Gs versus the LTEs. Here's some of the 2Gs: your flip phones, your notebooks, your tablets, your webcams, broadband cards. Those were what was popular with 2G, 3G. Now with LTE, we're going to start to be able to do all sorts of things. Your diabetic insulin monitors, gaming systems, cash registers, camcorders, refrigerators can all talk to each other. It'll be very interesting the more we get into this LTE. What about wireless LANs? Well, you have what we called Wi-Fi that was started out. That was the 802.11b standard. Basically, it was the first commercially viable standard for wireless LANs. And as you're well aware of, it doesn't work very well. Very unsecure. And then we went on and did more and more. Your Bluetooth network, you get up to about 30 feet on it. You can transfer things at a lower speed. That's where you're transferring between your phones. And don't ever believe it that Wi-Fi can get to 300 meters. The internet connects to the wireless access points that gives you the wireless stuff to any of your devices. Like I said, I'm trying to keep this 30,000 foot view. You'll get more of this in wireless. The development of the web between 89 and 91, and it was invented by Tim Berners-Lee at the European Particle Physics Laboratory, or CERN. And it was not really done by Al Gore. 1993, Mark Anderson and others at the NCSA created Mosaic, basically a web browser that would allow you to see things on graphics. In 1994, they released it, and it became what we know as Netscape. Netscape was the first web browser. In 1995, Microsoft said, oh, well, let's get into this. So they got into Internet Explorer. Then we got Google Chrome. We got Mozilla. We got Opera. We got Safari. And as you can tell, there's a lot of different types of browsers you can use. But they all come on what we call a markup language. You have certain different kinds of markup languages that will work with the web. But the web is based on what we call the hypertext transfer protocol. That means it can take any of the hypertext in markup languages and display them in a graphical environment. Some of those markup languages are GML, or generalized markup languages. They include your SGML, and it's just the early version of GML. Then you had HTML. That was really easy to use. It gave you predefined tags that you used to display information. Now we're in the extensible markup language that is being even more further defined by the W3C, and it's called extensible markup language, and it allows the user to create their own tags instead of the standard B, U, I, whatever. You can create them to be whatever you need it to be. That's what we call XML. Here's the difference of what an HTML code look like. You have the HTML, the header, the image, the title, things of that nature, and it shows you what it would display. An XML code will look something like this, where you can say to and from and heading and body. I mean, you can do back and forth. And here's some more different examples of an XML type. Web server software enables the web server to develop or see pages written in HTML or XML because of the HTTP request. The leading brands right now for web servers are going to be Apache and Microsoft's IIS. The basic capabilities, they provide security, they give you data capturing capability and search engine capability. And if you hear the term web server, it's really talking about the physical server that runs on the web server itself, not the server box. Specialized types, you can have database servers, ad servers, mail servers, video servers. You can make a server whatever you want it to be. A web client is any device that connects to that web infrastructure and displays the HTML pages from that server. Finally, what are some of the features? Well, you can have email, instant messaging, search engines, bots, which can be good, can be bad. You can do chats, music, video streaming, and you can have cookies. Like I said, if you have any questions, feel free to email me.